والآن سوف أقدم لكم آخر حلقة يمكن استعمالها أو تستعمل بالأساس خلال ال stepwise procedure أو يعني كل التطبيقات التي تستعمل من طرف الدستور الغذائي. وبالنسبة لهذا التطبيق هو خاصة يستعمل لاتخاذ القرار فيما يخص تحديد الحدود القصوى. فبالنسبة لبعض الملوثات وفي بعض المواد الغذائية فقد قامت الكودكس باتخاذ بعض القرارات في إمكانية استعمال بعض الميثودولوجيا تمكن من باتخاذ الحدود القصوى الملائمة. فأنا يعني أسطر على كلمة ملائمة لأن بالنسبة للكودكس نحن في صدد اتخاذ يعني أو تحديد حدود قصوى عالمية، وبالتالي يجب مراعاة بعض العوامل. من بين العوامل هي السيفتي أول شيء، يعني سلامة الغذاء. فهذا أول شيء يعتبر في يعني اتخاذ القرار المتعلق بالحدود القصوى أو كل المعايير الصحية. وثانيا أن لا تكون هناك عراقيل بالنسبة للتبادلات التجارية، وهذا هو ما تحدث عنه رفيقي أمين باعتبار الكالكوليشن أو rejection rate الذي يعطي لنا نظرة يعني precise idea حول كل يعني السلع التي سوف يتم يعني to reject them for trade إذا قمنا باعتماد الحدود القصوى. فالتطبيق الذي سوف أتحدث عنه هو أو الميثودولوجيا سوف تمكننا باستعمال الطريقة التي تحدث عنها في التقديم الأول، أي هو تقييم التعرض الناجم عن الغذاء. سوف نستعمل هذا الفورمولا ونقوم باستعمالها لدراسة مدى تأثير الحدود القصوى المعتبرة أو hypothetical mls، مدى تأثيرها على الانتيك أي الجرعة المقدمة من الغذاء بما يخص الأخطار. فقبل ذلك بما أنه هو التقديم الأخير سوف أقف شيئا ما لكي أذكركم بكل المراحل التي أشار إليها بروفيسور سامويل، ولكن كذلك كل يعني العروض التي قدمت. فالكودكس تعتمد بالأساس على منهاجية يعني متكاملة. It's a really structured process for the establishment of safety standard. عند يعني في البداية فنعتمد على كل التوصيات المقدمة من طرف الهيئات التي تقوم بتقييم المخاطر والمعتمدة من طرف الكودكس. ورأينا أن هذه الهيئات هي جيكفا بالأساس وجي ام بي ار إلى غير ذلك من المؤسسات الأخرى التي تقوم بتقييم المخاطر. وهذه الهيئات تقدم لنا توصيات على شكل health-based guidance value, safe levels, toxicological reference values، وكل هذه المعطيات تستعمل في تحديد الحدود القصوى. فهي بالأساس هي الحلقة الأولى التي تعطينا نظرة أولية حول إذا كان هناك مشاكل أو مخاطر مرتبطة بالغذاء. بعد ذلك إذا في بعض الأحيان تستند كذلك الكودكس على أعمال working group كودكس working group. فخلال هذه المجموعات العمل يتم من خلالها مناقشة إمكانية تحديد حدود قصوى، وهذه الحدود القصوى تعتمد على منهجية علمية. هناك يعني تطبيقات تم اعتبارها واعتمادها من طرف الكودكس لتمكن من اتخاذ القرارات الملائمة، وباعتبار يعني بعض التطبيقات التي سوف أشير إليها الآن. بالنسبة إلى بعض الملوثات التي يعني جيكفا أو الهيئات لم تقر أو لم تحدد حدود safe level إذا صح يعني التعبير. فبالتالي فالمنهجية المتبعة سوف تكون مختلفة بالنسبة لهذه الملوثات. فنستعمل RRR principles as low as reasonably achievable وكذلك rejection rate. فأنا بالنسبة لهذا التقديم سوف I will focus on the impact of mls for the reduction of intake exposure. So in this talk, I will outline this methodology for conducting primary exposure calculation of effects of ml on the reduction of the dietary exposure. And I will demonstrate how these calculations can inform codex deliberations. This deliberation normally is conducted within the electronic working group. And to share a simplified case study using hypothetical MLs to highlight practical applications. So this work supports improved data collection strategies and stronger scientific justifications in codex discussions, and also enhanced regional participation in the standard setting process by using all the data provided by all the countries. So the key component of this process is the primary calculation of the potential impact of hypothetical maximum level on dietary exposure to specify contaminants for targeted commodities. The methodology is designed to estimate how different ML scenario may influence overall dietary exposure levels, thereby aiding in the assessment of risk reduction benefits. As I mentioned in my previous talk, we have in the first hand the risks, and we should have benefits when we are establishing MLs. So we study, we try to balance all these two parameters. The approach typically involves the use of food consumption data and occurrence data. We use these parameters to conduct dietary exposure assessment. And after we also do the same calculation by considering all the hypothetical ML that was mentioned by Amin in its presentation. These calculations serve as a screening tool to inform whether proposed ML could effectively reduce exposure. When we establish our hypothetical ML, we will try to use them as an input in our calculation for dietary exposure assessment, and we will see if this exposure will help us. We will have a reduction of the intake, and we compare it with all the MLs considered during this calculation. So what are the benefits of this methodology? So first, we assess whether proposed standards are protective of public health. We talk about the intake. So we will see if the ML by using the ML in the calculation of the intake, it will provide us a reduction of this intake. And also to adapt international guidance to local food consumption patterns and contaminant occurrence. We have as a benefits to support the development of science-based food safety standards that reflect local environmental and dietary realities while aligning with Codex principles. And it supports the application of ARALA principles. As I said, in some cases, we don't have safe level, so we have to apply this methodology. We should have maximum level to establish these maximum levels for those commodities, considering these hazards, for example. The example is the lead. If we considered lead, we don't have the safe level, so we should apply ALARA principle to establish our limits. Here in this slide, just I want to show you some examples. During the CCF 18, this methodology was applied in different work done by the electronic working groups, and it was applied when for the establishment of maximum level for lead in certain food categories. Also in the analysis of the occurrence data of lead in spice mixtures, and also for the analysis of occurrence data on aflatoxins in cereals. If you come back and you look on the reports of the electronic working group, you will find that this methodology was applied, and it was the basis for the establishment of maximum levels. And now I want just to provide you a general concept of this methodology. First, we have to calculate, or we have to apply the methodology of dietary exposure assessment to have an idea about the current dietary exposure. And after that, we can do the same calculation, but with using the MLs as an input. And after that, we can by having all these results, we can use them to calculate the intake reduction under the application of MLs. And then we can respond, have as questions, and we should answer to some questions. For example, is the current exposure is close to or exceeding the toxicological reference value? Does the proposed ML significantly reduce health risk? And what are the new MLs that we can apply for this commodity and regarding the hazard that you are considering in our calculation? So the first step, if you remember the methodology that I explained you to conduct dietary exposure assessment, first of all, we have to define our context and also the scope of our intervention or methodology. So we only identify the contaminants of concern, specify the food commodity under consideration, and also to state the proposed ML. So we have to define our hypothetical ML by using the methodology explained by Amin. For example, we can have another scenario. We have already established ML, and we want to have less than this ML. For example, we have 0.2 milligram per kilogram. We want to establish 0.1 milligram per kilogram. So then we can apply this methodology and to see if the new ML that we want to establish will give us, let's say, benefits in terms of intake. If this ML will reduce more the intake, and it seems that we will have our consumer more protected by the new ML established. So we have to apply this methodology also. And also we have to describe the regulatory context of rationale. For example, if you want to have a public health or trade concerns or alignment with JECFA, so it depends on the target, it depends on what we want to do with this with the calculation. Second step is to collect data. So it's really important. We can't do it if you don't have data, because we will use the dietary exposure assessment. So occurrence data, food consumption data, and also body weight and target population. Since exposure is often expressed relative to body weight, but body weight we can take as a reference value 70 kilogram. But if we want to do this approach considering infants, we have to change the body weight that correspond to this population. And then we do as I mentioned, our first calculation to estimate the baseline intake, and then we use the data that we collected before, and we have the formula that you know very well. You have consumption data multiplied by mean concentration, and we divide by body weight. We can use the deterministic approach depending on data availability. After this calculation for baseline exposure, we calculate a new intake estimate or new dietary exposure by using and replacing data value of occurrence with hypothetical MLs. And we use the food consumption data. We will have a new result from this calculation. And after that, we estimate the estimate exposure under this hypothetical ML, and we calculate the reduction rates when using both of the two calculations. The formula is really very easy to apply. And then we can summarize all our output, our exposure estimates under all scenarios, and we will have a very good idea about all the benefits that we can have by taking into account all this maximum or hypothetical maximum level. And we can highlight in this table the exposure reduction, feasibility of MLs by also taking into account simple rejection rate, and also the potential impact on trade by analyzing this simple rejection rate. And this analysis will provide a clear and evidence-based recommendation for the establishment of MLs. It's very simple application. We can as you see here, it will give you really a good idea about all the propositions that we can have regarding the MLs. And if we look on all the reports of the electoral working group within the Codex framework, we will found the same methodology applied by the different working group. So as a recommendation for the application of this methodology, so with appropriate investments in data generation systems, Arab countries can adopt this methodology to enhance consumer safety while supporting trade, food trade, and regulatory harmonizations. So first of all, we have to strengthen national contaminant monitoring program and encourage regional data sharing to improve the quality of occurrence data. Also, we have to conduct national food consumption survey. It's very important. As you see, among all the parameters that we use in our calculation, we have consumption data. So we have to do this survey to generate our own data. To enhance regional cooperation for technical capacity building and harmonized risk assessment practices, use the appropriate to set science-based MLs, protecting consumer health while supporting fair trade in our region, and to integrate the methodology into national food safety regulation to ensure consistent and transparent decision-making. So it was my last slide. Thank you very much for your attention. I hope that you had all the methodology linked to the establishment of MLs. So thank you very much.